For this demonstration, we're going to show you how to calibrate a Mac computer over the network using Client 3. I've opened our Monitor Advanced workflow, and now I'm going to set up the calibration. So I'm going to select Local or Networked Calibration. I'm going to select Networked Computer, Target Operating System, Mac, Single or Multiple Monitors. I'm going to select Single. We'll go to Next. Now we're going to connect to Client 3 as both the pattern source that's going to display the test patterns and as the target display, which Client 3 is going to act as a calibration profile manager. We've already installed Client 3 on our target Mac computer, so now we're going to connect to the pattern source, which will be Client 3. So we're going to select the computer from the list. So after it connects as the pattern source, you can see up here, these are the three tabs in CalMAN. The left one's our meter, center one is our pattern source, third one is our target display. So you can see now we're connected as a Client 3 pattern generator. So now we will go to Next, and we will once again connect to Client 3 as the target display. Now this particular Mac is hooked up to an external monitor, and that's why it's showing up right here as this profile. If you had multiple monitors, they would be in the list, and you would want to select the one you were calibrating. The next step in the process is to find our meter. I have it connected to the machine we're running CalMAN on via USB. So I'll hit the Find Meter button, and since it's not one in this list, this would be if you had a high-end device. By default, this is checked, and when we hit search, it searches for all the common meters like the i1 Display Pro, our C6 and C3, as well as the i1 Pro and other X-Rite meters. Essentially, if it's not in this list, then you would just leave this checked and hit search. Okay, now that our meter is found, we're using the SpectraCal C6. This particular display is a ccfl backlit LCD. So I'm going to select LCD CCFL as our meter mode. If you're unsure of what the display technology is that you're calibrating and don't know which of the meter modes to select, email our support line, which is support@spectracal.com, and we can help you figure it out. I have put the meter on the display that's hooked to the Mac, and we're connected, and we have the correct display mode selected, so we're going to go to Next. And now we will select our calibration targets. By default, we set it to sRGB and sRGB gamma and a white point of D65. That's the most common target that you'd use to calibrate a computer monitor. So I'm going to leave it at the defaults because that's what we're calibrating to. Now this is our pre-calibration capture page, where we will essentially measure what the display is doing before it's been calibrated. So then we have a baseline to compare it to the results to it after calibration. So we have a before and after look, so you can see how much of an improvement there was after calibration. So I'm going to hit the Read Series button, and it will take a series of readings of the grayscale and the color gamut. This will take a few minutes, so we'll be back after all the readings are done. Now that our pre-calibration measurements are complete, you can see that our display is deficient in blue, and essentially if this was all perfect, the red, green, and blue lines would all be lined up right on 0. So because this is below 0, that means there's not enough luminance in the mid-range and the gamma, and then the blue is deficient. So that will all be calibrated out. Go to the next step, which is to check for clipping. So I'm going to run a read series. And this is showing me that there isn't any clipping. If there was, then the red, green, and blue lines at some point would plateau off and kind of go straight across. But it seems to be fine, so we don't have to worry about if you were to see some clipping, you would want to lower the contrast in the display, and that should relieve that error. Since we're calibrating a standalone monitor hooked to this Mac, we're going to use its internal RGB controls, to fine-tune the monitor before we do the rest of the calibration process. Getting the monitor as close as possible with its internal controls reduces the chance of having to make big swings with the gamma table in the computer itself's calibration process, and that could bring out artifacts or banding if you're making too big of an adjustment in there. So I'm going to hit read series. This particular display just has an RGB gain control. It doesn't have high and low, so I'm going to focus on the RGB high. What we're seeing right here is the blue is so deficient, it's off the chart. So I'm going to reduce the red and the green to even it out with the blue channel. So what I'm going to do is I'm going to hit the read continuous button. Right here is that you can select which one you want to display, which pattern you want to display. I have the white one selected. If you had a 2-point control and you wanted to do a read continuous on the low, the RGB low, you could click here and then hit read continuous. So I'm going to click on the white, hit read continuous, which looks like a little infinity symbol, and it's going to over and over take readings. And then I'm going to go into the menu of the display and reduce the red and the green in the RGB controls for the white balance to match it up with what the blue channel is to reduce our color error. So I'm bringing down the red right now. This is a relative chart, so you're starting to see the blue come in. Okay, now I'm going to reduce the green. Now it's about perfect. So I'm going to hit stop. Now I'm going to do a read series again so we can see what the high and low did. They're both pretty good now. Average LTE of 1.6. Now that the monitor is accurate as it can get using its internal controls, we're going to go to the next step, which is to set the luminance. So I'm going to do a read single. It's going to measure what the luminance is. I usually like to do about 150 nits, or CDM squared. Nits is short for CDM squared, for an office environment, and that's what this display is going to be used as. I'm going to hit read continuous. And I'm going to reduce the brightness slightly until we get it down to 150. Okay, now that's at 150. I'm going to hit stop, and we're going to go to the next step, which is creating the 1D lookup table in the graphics card of the computer. We hit the autocal button. The 1D lookup table corrects the grayscale, gamma, and the white point at multiple points along the grayscale. This is a completely automated process, so I'm going to hit OK to start the autocal process. It's going to take a few minutes, so we're going to be back after it's done. Okay, now our grayscale autocal has been completed. Our delta E is now 0.4 average. Go to next. Now we're going to check our luminance again, because a lot of times once you balance the RGB perfectly, you lose luminance. But since we kind of tweaked it in the display itself, we might have not lost that much. So I'm going to do a reading. It's right at 150, so we're still good. We're going to go next. Now this is the part where we create our ICC profile. This essentially characterizes the display so the operating system can do proper color transforms, so the content, when it's tagged a certain color space, will look correct on your display. So we will hit our autocal button and hit OK, and it will read the primaries and the grayscale, and it will automatically load the ICC profile into client 3 over the network. It's going to take a few minutes, so we're going to be back after it's done. Now our ICC profile has been created. So next step is to verify our calibration. It's already been pre-populated with our pre-calibration data from when we did our pre-calibration measurements. So now we hit our read series button, and this is going to take a few minutes, so we'll be back as soon as it's done. Okay, now our post-calibration measurements are complete. We got excellent results. Color checker Delta E 2000 of 1.0. The pre-calibration was 5/5. Post-calibration of the grayscale was 0.65. The pre was a little over 6.5. So these are excellent results. So our next page is a visual verification where you can look at our color comparator. This shows you the pre-calibration grayscale. This is the actual measured, this is the target. So you can see there's definitely visual errors. This is post-calibration. This is the pre-calibration of the color gamut. This is the measured, this is the target. This is post-calibration. You can see you'd be hard pressed to visually notice a difference. Sometimes on the fully saturated colors, if the primaries are slightly undersaturated, you will see a little desaturation here. That's just inherent in the physics of the monitor. We can't fix the fully saturated red, green, or blue if they're undersaturated. So that's the end of the process. If you had a second monitor hooked to the same machine, you would start the process over, but you would select, when you connected to client 3 as the display, you would select the second monitor from the display mode selection dropdown. It would show up, the name would be below the one you just calibrated. So you start the process over and you would select that second monitor, move the meter from your current monitor to the second monitor, and do the whole process again. And then you should have nicely matching monitors.